the word obsolete means, right? This whole technique has become obsolete because we now have good technology. You follow me? Advanced technology with binomial buttons that you can just go boom, 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 get the exact answers. So on that note, I know everyone in here practices the problems on the textbook. The first thing is, I'm going to give you the good textbook problem from our practice for you to work at home. It's number 21. This is for practice. And yes, and I already have this on your practice sheet. This is on page 392. This is for your homework. This is in section 7.4. But what I'm going to do is, I want to write down all the answers if you use the binomial button, okay? So would you write these down? These are just for you to check. That's the answer of letter A. You should get about 0.928 for letter B. 0.003 for letter C, and letter D, 0.536. And just put them in your notes and say, I will check these. Check. That's for you to check after you do problems. And I want you to use which method?
Binomial program.
Yeah, so use the binomial method. What I mean by binomial method, I want you to use the binomial probability distribution. I think you all follow me. And when it's like I'm an English teacher and I need you all to write a paper. This is an analogy. It's like me saying, everyone, you got to write your paper with a typewriter. Has anybody ever seen a typewriter? Have you seen them? You know, I might be the only one in the room who grew up with them, maybe, right? Did you ever use it?
Yeah.
Oh yeah, and everyone's like, ching. I mean, it's just, yeah, it's very, very tedious and stuff like that, right? With the typewriter. Now we have, you know, computers. We've got these Microsoft Word. Type that stuff up. We fine. So when check these, because the answers in the back of the book are going to be a little bit off.
Oh,
The answers in the back of the book, guess which technique they used? Hit that page, what page was that? Where they approximated. So Art, that's why I need us to put these down, because the answers in the back of the book use the approximate normal technique, and they're going to be a little bit off. They didn't do it with the binomial buttons. These are with the binomial buttons. And the whole idea of this, Autumn, you're with me, these are exact answers. And it's easier to do it this way, with our technology. So we're not using that obsolete technique. You follow me? Oh, good. And for practice, we're just going to do a couple of these. Sound good? I want us to do an exactly. Remember this before? All right, we're going to do an exactly. Let's do one with, let's definitely do one with at least. Remember at least? And then we'll finish up with between.
Can I ask you a question?
Sure.
This binomial doesn't have anything to do with the Pascal's triangle binomial, does it?
No, it doesn't. But in that's because that's two things, right? But it doesn't. It doesn't.
Okay.
That's interesting. Yeah, you knew about Pascal's
Oh,
triangle.
yeah.
All right, everyone. So for our last problem, I'm going to take a problem. I actually got this out of the earlier edition. Because when you had the, the 4th edition? This is from his 3rd edition. So this is the question I'm going to put on the board. I just found the topic interesting to me. It's called Murder by Firearms. All right, so this is titled Murder by Firearms. All right. Murder by Firearms. And this is what they did. They looked at 50 murders randomly. So they already occurred. But they randomly chose 50 murders. They already had happened. All right. So, and that's your number of trials, isn't it?
Mm-hmm.
All right. And they wanted to see, here's the question that we're looking at. We want to see if these murders were committed with a firearm or not committed with a firearm. Is that binomial?
Mm-hmm.
Yeah. Were these murders committed with a firearm or not a firearm? Binomial experiment, right? Binomial distribution. So we're going to look at 50 random murders. Now, the probability is 67.8%. 0.678. 67.8%, everyone, of murders are already committed with a firearm. Where's that number coming from? That's from like a crime report. Someone's been already doing statistics on this, right? That's given to us, that's something that's given for the population, roughly 67.8% of murders are committed with a firearm. I'm going to look at 50 random murders. It could be in the state of Maryland. Well, letter A, here's my first question. the binomial distribution approximate normal? That's my first question. All right. Is the binomial distribution approximately normal? I won't abbreviate. You can do the same thing. Is the binomial distribution approximately normal? What do we check?
NPQ.
MPQ. How high is it got to be?
What 10?
You go, oh, do we have enough information here? Yep. I give you the N, I give you the P. How do you get Q though?
1 minus P.
All right, on N times P times Q. 50.678. And I'll let you do it on your calculator. What's 1 minus 0.678 on a calculator?
0.322.
0.322, and we just want to say, see if this number is greater than 10. If this is greater than 10, we're going to say yes, right? This is Y. We're going to go Y. Yes or no? Y? Here's our reason.
Yep, 10.9.
The answer?
Yes.
It would be Bell-shaped. I just want to put that out there. Now we got to answer some questions. Now in the textbook, you would have an option, but we're going to use which method? Let's use the binomial method. So here's my first question, right? The word exactly. Approximate the probability that exactly 40 murders committed with a firearm. All right, so what's the probability exactly 40 out of 50 were committed with a firearm? I didn't put all the words, but the question is, what's the probability exactly 40 out of 50 of the murders that I randomly chose were committed with a firearm, where this is what the going rate or chance of someone being murdered with a firearm is? How do we do that in a calculator? Binom PDF, right?
Mm-hmm.
You put the N here, you put the P here, and you put the X here. So this was 50, this was what? 0.678, what was this? That's got to be the successes, right?
Yep.
Sounds weird though, doesn't it? Success, murder, I know. The number of successes is what? 40. Holland has the newer calculator, it goes vertically. When she types this in, they call this the number of trials, number of successes, the P. And when did you hit binomial P, not normal, right? We're jumping from the normal back to binomial. What do you get?
0.022.
0.022? Is that okay, man? Letter C. And how about at least? What did they ask you? At least 35 murders. That's out of the 50. Committed with a firearm. Do you remember how to do this with the 1 minus?
Mm-hmm.
I want to do this. I'm going to do calculator. 1 minus binom, not P, but
C.
CDF, the binom CDF. I'm going to accumulate all the way up
To 34.
to
34.
34. Thanks, Art. And you know what I'm doing? I'm subtracting out 0 to 34. So I'm left with the 35 and higher. Does that make sense?
Mm-hmm.
I'll do it too. Then we'll do a pure between, we'll be done. Minus. And we're back to the binomial, huh? 1 minus binom CDF 50, comma 0.678, comma 30. Oh, not 5, but 34. Remove 0 to 34, I'm left with about 0.435. All right. And then here comes D and E. D, what's the probability that fewer than 125, or excuse me, that's the problem in the book. Fewer than 25 murders How would you do that?
That's binom CDF, right?
Yep. And if it's just fewer than, you just do binom CDF 50 comma 0.678. This is for fewer than. So you're just doing less than, you don't need 1 minus. You're just going to accumulate all the way up to, fewer than doesn't include the endpoint though. So I'm going to go all the way up to 20, what's one less than 25?
24.
And the reason I'm doing that one is because the wording fewer than doesn't mean less than or equal to, it just means less than. Fewer than means less than. So I'll let you all do that one. And then we'll end with an E. We'll do a between. Let me know what you get on that though. And then the last one will be a between. Yep. And 35. Inclusive. Hey, what'd you get for this one?
0.0289.
There's
Like
two
that?
zeros.
There's 2 zeros, it's point.
Oh, thanks. 0, 0.
28.
So this would be what? I find this interesting. I just go get a random sample of all these murders that already occurred, randomly chosen. The chance is that 25 out of 50 of them, all right, or fewer, were committed with firearms. You know, and you say like, how were they murdered? I don't know, pushed out a window, drowned, you know, all these things, choking. The chances would be really, really, really small. So it's that most murders are committed with what? Firearms. Okay. And then letter E. Probability between 30 and 35. Okay, how do we do that? Well, I'm not using the 1 minus, but I'm going to use the cum button. Binom CDF, that means cumulative. Let's go up to the 35.
Yep.
All right. 0.678, 35. So I start out, everyone, what did I just do?
It took cumulative all of them to 35.
I did 0 to 35. But I only want between 30 and 35. So I have to subtract out. Michael, good. Subtract out the
29.
good. And what do I want to remove? Because I got, this is 0 to 35, right? This is 0 through 35. I want to remove from the 0 to 35, the 0 through 29, these, right, it's a discrete variable, all those probabilities, and you'll be left with your answer. So what's binom CDF this minus binom CDF this? And as long as we get 2 people to get the same answer, I'll put it on the board, we're done. What do you all get? 0.5874. Do we have a second on that? I'll wait. We're just going to see if anyone else gets it. That's 2, that's right. Good job. Hey everyone, super job. Now, just so you know, as you're packing up, hope you have a great weekend. Celebrate Easter, happy Easter. I do want to point out, remember with our schedule, because of the 2 days we lost, the test isn't like next Tuesday. The test is April 5th. It's a week out. Does that sound good? So we got a whole nother week. We just do 2 more sections though. It's all normal CDF stuff. Have a great weekend.